A function that meets two of the three conditions for continuity at x equals 1, describe which conditions are met and which one is not. All right, I'm just going to write the three conditions for continuity. Our first condition would be that f of 1 is defined. My second condition for continuity as the limit as x approaches 1 exists. And then my third condition would be f of 1 equals the limit as x approaches 1. Okay, so if two of them are going to be met, I'm going to have number 1 be met and number 2 be met, and then number 3 is not met. And I guess you could vary it a little bit, but that's pretty much what we're going to have here. Okay, so f of 1 being defined means there is a point at x equals 1. So I'm just going to make a point at x equals 1. So that one is set, and we could put f of 1 in this case would equal 1, so that is fine. Okay, the next one is that the limit exists. So as I'm coming in from the left and I'm coming in from the right, we are getting a limit, so it's going to be the same value, but I don't want the third condition to exist, so I don't want those answers to be the same, so I'm actually going to put a hole coming up here, so I'm going to have something like that. So you'll notice as I'm coming in from the left and I'm coming in from the right, my y value that I'm heading towards is 2, so my limit in this case is equal to 2. So it does exist, but then my third condition is not met because f of 1, which equals 1, does not equal the limit, which is 2. So that one is not met. So notice that 2 of my conditions are met, the third one is not. Okay, number 9, the position of a particle moving on a line is s of t equals 3 cosine 2t minus 5t using t is greater than or equal to 0, so my time cannot be negative. It says to find formulas for velocity and acceleration. So on these ones, to get the velocity, if I'm at position, the velocity is just the first derivative, and then the acceleration will be the second derivative. Okay, so if I take the derivative of this, I'm actually going to call this u. So this is really 3 cosine u minus 5t. When I take the derivative of 3 cosine u, I'm going to get negative 3 sine u, but then don't forget we have to multiply by the derivative of the u, which in this case will be 2. So that will become negative 6 sine of u, which was 2t, and then minus the derivative of 5t is 5, and that will give us the velocity formula. Okay, and then to get the acceleration, we get to do that again. So I'm going to have negative sine u, and so when we take the derivative of that, we'll get negative 6 cosine u times the derivative of the u again, which will be 2. So that will equal negative 12 cosine u, and u again is 2t, and then minus the derivative of 5 is just 0. So that would be our derivative. That would be my velocity and my acceleration. Okay, part B says to find the velocity of the particle at t equals 8.6. So we're going to go into the velocity formula, and we'll put 8.46 in for the t. And we will allow this to be a calculator-aided problem. If you type that in, making sure that you are in radians, we should get an answer of 0.618. So that would be my velocity. We don't need units because no units were given in the problem. Okay, part C says, for what values of t is the particle moving to the left, to the right, and not moving, and then to justify your answers. I am going to switch this one just a minute. We need to have some intervals on this one because otherwise the picture gets pretty crazy. So let's just go the interval from 0 to 4. Okay, on this one, since we get to use our calculator, if my particle is moving, that definitely deals with the velocity. So if I want to know whether the velocity is going left or right, I really want to make a velocity chart. So in order to do that, we would want to set the velocity equal to 0. And the easiest way to do that would be to draw a velocity graph. So if you graph the velocity, you take this formula right here and graph the velocity in your calculator and just change the window to x min equals 0 and x max equals 4, you are going to get a picture. Just a second here. 2, 3, 4. You are going to get a picture that looks something like that. Okay, so that's a picture of the velocity. So if I want to know where does the velocity equal 0, I'm going to use my 0 feature to find where that is happening. So I found when I did that, I got 2.063, and then I also got 2.649. Okay, and then I can use the picture to help me figure out where my velocity is positive and negative. So before 2.063, my velocity is below the x-axis, so that would be negative values. Between 2.063 and 2.649, my velocity is above the x-axis, so my values will be positive. And after 2.649, my values will be negative. So if I want to know where's the particle moving to the left, the particle will be moving to the left wherever my velocity is negative. So that would be from 0 to 2.063, and then also from 2.649 to 4. And it does say to justify my answer, so this will be because velocity is negative. And then where's my particle moving to the right? That is going to be from 2.063 to 2.649, and that will be because the velocity is positive. And then it does give one more thing, not moving, so not moving. Where is it not moving? Well, that would be where the velocity equals 0. So it's going to be at t equals 2.063 and 2.649. And again, that will be because velocity is 0. If the velocity is 0, the particle is not moving. Okay, question 10, multiple choice. Given that f of x has a relative minimum at x equals negative 3, choose the correct statement. So if we have a relative minimum at x equals 3, we know things are happening with f prime. So I'm going to make myself an f prime chart. I'm going to put negative 3 in the middle. If I know something that has a relative minimum, f prime must go from negative to positive, because that would mean the function is decreasing and then increasing. So we're going to use this f prime chart to help us answer this question. So part A says f prime is negative on the interval negative 3 to 3. Well, 3 is not even on my chart, and definitely from negative 3 to onward it's going to be positive, so nope. F prime is negative on the interval negative infinity to negative 3, so that is true. C, f prime is positive on the interval negative 3 to infinity. Definitely, according to my chart, that is also true. F prime is negative on the interval negative 3 to infinity. Nope, because it's positive. And so I got B and C as my answer, which would be choice E.